Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone. My name is Ratna Dewi Rosyida. In this video, I would like to present mathematics learning material on number pattern as part of the requirement for the English Mathematics course. This learning video is designed to help students understand mathematical concepts clear through structural explanation and example. This video was created as part of an assignment for an English mathematics course. Have you ever noticed a number pattern like 1, 2, 4, 8, 16? At first glance, it seems simple, but behind this sequence of numbers lies a special rule that is interesting to understand. In this lesson, we will explore how this pattern is formed, discover the rule, and see its application in various everyday life situations. By understanding number pattern, you not only learn to count but also practice logical and systematic thinking skill. Let's explore together and discover the fun. Let's recall. Consider the following number sequence 1, 2, 4, 8. Can you identify the pattern in this sequence and write the next number, determining the pattern? To find the pattern, consider the relationship between two consecutive numbers. 1 to 2 multiplied by 2, 2 to 4 multiplied by 2, 4 for 8 multiplied by 2. It can be seen that each number is obtained by multiplying the various number by 2. Determining the next number using this rule, 8 times 2 is 16. 16 times 2 is 32. 32 is times 2 is 64. So the complete number sequence is 1, 2, 4, 8, 16, 32, 64. The number sequence above is called a geometric number pattern. Types of number pattern: odd number pattern and even number pattern. An odd number pattern is a sequence of numbers whose members are all odd numbers. Example 1, 3, 5, 7, 9. And term it mean if n1 then u1 is 1. If n2 then u2 is 3. And n3 then u3 is 5. And so on. An even number pattern is a sequence of numbers whose members are all even numbers. Example 2, 5, 6, 18. And term formula. In n1 then u1 is 2. If n2 then is 4. If n3 then u3 is 6, and so on. Okay, triangular number pattern is a sequence of number formed by adding natural number in order. This number can be arranged using dot to form triangular shape, which is why this pattern is called the triangular number pattern. The sequence of triangular number is 1, 3, 16, 15, and so on. Each term is in this sequence is obtained by adding the next natural number to the previous term. For example, 1 plus 2 equals 3, 3 plus 3 equals 6, and 6 plus 4 equals 10. Because of this process, the difference between consecutive terms increases by 1. The difference are plus 2, plus 3, and so on. To determine the nth term of the triangular number pattern, we use a formula. The formula is read as U sub n equals 1 half time n times n plus 1. This formula helps you find any term without listing all previous terms. For example, to find the fifth term, we say U sub 5 equals 1 half time 5 times 6, which equal 15. By understanding this pattern and using the formula, student can easily identify and determine any term in the triangular number pattern. Next, square number pattern is a sequence of number formed by squaring naturally number. This number can be arranged using dots to form a square shape, which is why this pattern is called the square number pattern. The sequence of the square number is 1, 4, 9, 16, 25, and so on. The first term is written as 1 squared equals 1. The second term is written as 2 squared equals 4. The third term is written as 3 squared equals 9, and so on. As the position of the term increases, to the size of the square also increase. To determine the nth term of the square number pattern, we use a formula. The formula is read as U sub n equals n squared. This means that the value of each term depends on its position in the sequence. For example, to find the fifth term, we say U sub 5 equals 5 squared, which equals 25. By understanding this pattern and its formula, student can easily find any term in the square number pattern. Okay, next. Rectangular number pattern is a sequence of numbers that can be formed by arranging objects into a rectangular shape. The sequence of rectangular number is 2, 6, 12, 20, 30, and so on. This pattern can be written as the multiplication of two consecutive natural numbers. The first term is written as 1 times 2 equals 2. The second term is written as 2 times 3 equals 6. The third term is written as 3 times 4 equals 12. The fourth term is written as 4 times 5 equals 20. And the fifth term is written as 5 times 6 equals 30. In general, this pattern can be expressed in the product of a number and the next natural number. To determine the nth term of the rectangular number pattern, we use a formula U sub n equals n times n plus 1. This means that each term is obtained by multiplying a natural number by the next natural number. For example, to find the fifth term, we say U sub 5 equals 5 times 6, which equals 30. By using this formula, student can easily determine any term in the rectangular number pattern. Pascal number pattern is a number pattern arranged in a triangular form known as Pascal triangle. Each row in this pattern contains numbers that follow a specific rule. The first row consists of only one number, 1, and the sum of this row is 1. The second row is 1, 1, and the sum is 1 plus 1 equals 2. The third row 1, 2, 1, and the sum is 1 plus 2 plus 1 equals 4. The fourth row is 1, 3, 3, 1, and the sum is 1 plus 3 plus 3 plus 1 equals 8. To form Pascal number pattern, we follow several steps. First, write the number 1 at the top as the first row. Second, each row always begin and end with the number 1. Third, the number in the middle of obtained by adding two numbers that are located diagonally above them. This rule is applied repeatedly to form the next row of the pattern. There is also a formula to find the sum of number is the nth row of Pascal number pattern, u sub n equals 2 to the power of n minus 1. This means that the sum of the number in each row doubles as the row number increases. By understanding Pascal number pattern and its rule, students can identify the pattern easily and calculate the sum of any row correct. Arithmetic pattern is a number pattern in which the difference between consecutive terms is constant. An example of an arithmetic pattern is 2, 4, 6, 18, and so on. In this sequence, each term increases by 2, so the common difference is 2. An arithmetic pattern is defined as a sequence of numbers that has a fixed difference between two consecutive terms. To find the nth term of an arithmetic pattern, we use formula u sub n equals a plus n minus 1 times b. In this formula, a is read as the first term, b is read as the common difference, and n is read as the term number. This formula helps you determine any term in the sequence without listing all the previous term. For example, in this sequence 2, 5, 6, 18, the first term is 2, and the common difference is 2. To find the 50th term, we say u sub 5 equals 2 plus 4 times 2, which equals 10. By using this formula, students can easily determine any term in an arithmetic pattern. Next, geometric pattern is a number pattern in which each term is obtained by multiplying the previous term by a constant number called the ratio. For example of a geometric pattern is 3, 6, 12, 24, 48, and so on. In this sequence, each term is multiplied by 2, so the ratio is 2. A geometric pattern is defined as a sequence of numbers where the ratio between consecutive terms is constant. To find the nth term of a geometric pattern, we use a formula. The formula is read as u sub n equals a times r to the power of n minus 1. In this formula, a is read as the first term, r is read as the ratio, and n is read as the term number. Now consider the following question. Given the number pattern 2, 4, 8, 16, and so on, determine the fifth term. In this pattern, the first term is 2 and the ratio is 2. To find the fifth term, we say u sub 5 equals 2 times 2 to the power of 4. This is 2 times 16 equals 32. Therefore, the fifth term of the geometric pattern is 32. By using the formula, students can easily determine any term in a geometric pattern. Applying number pattern concept in daily life. One example of applying number pattern in daily life is through a saving activity. Suppose Siti save money every week. The amount of money she save increased by 5,000 rupiah each week compared to the previous week. In the first week, Siti saved 10,000 rupiah. The question is, how much money does Siti save in the sixth week? From the information given, the first term is 10,000 rupiah. The common difference is 5,000 rupiah and the term number is 6. The situation follows an arithmetic pattern because the amount increased by a fixed difference each week. To find the sixth term, we use the formula for the nth term of an arithmetic pattern. U sub n equals a plus n minus 1 times b. To find the sixth term, we say u sub 6 equals 10,000 plus 5 times 5,000. 10,000 plus 25,000 equals 35,000. Therefore, the amount of money saved by Siti in the 6 weeks 35,000 rupiah. The example shows how arithmetic pattern can be applied to solve real-life problems such as planning, saving regularly, and systematically. Okay, next group task, bacteria grow. A bacteria colony initially consists of 100 bacteria. Every hour, the number of bacteria doubles. The question is, how many bacteria are there after 5 hours? The situation follows geometric pattern because the number of bacteria is multiplied by the same number each hour. Given the first term is 100, the ratio is 2, the time is 5 hours. To find the number of bacteria after 5 hours, we use the geometric formula. The formula is read as U sub n equal A times R to the power of n minus 1. Now we substitute the values. U sub 6 equals 100 times 2 to the power of 5. This is calculated as to the power of 5 equals 32, then 100 times 32 equals 3,200. Therefore, the number of bacteria after 5 hours is 3,200. Correct answer A, 3,200. Okay, hopefully this video can be a useful learning research and support students in improving both their mathematical understanding. Thank you for watching. Bye bye. Wassalamualaikum warahmatullahi wabarakatuh.